Hello, class. Well, today we're going to be talking about what makes a linear equation. So, get started here. For an equation, okay, for an equation to be linear, okay, the graph of the equation must make a straight line. So here's the deal. For the rest of the year, we're going to be talking primarily about linear equations. When I ask you what kind of line it is, please don't tell me that's straight, okay? This is Algebra 1. Pretty much every line we deal with is going to be straight. But in this unit, we're going to talk a little bit about whether or not an equation gives you a straight line. You need to be able to recognize that it's a straight line. So you must be able to write the equation in the form ax plus by equals c, okay? Where a, b, c are all constants, okay? A, b, and c are all constants. If you can't manipulate it to that form, you don't have a straight line, okay? If you cannot manipulate the equation to that form, it is not a linear equation, okay? So that's the big deal of it right there, okay? If you can't get it into that form, it's not a linear equation. Okay, so let's talk about attributes that do not make linear equations. So if you have any of these attributes, this means you do not have a straight line. These are not linear equations. So the first one would be any exponents on the variable. So if you have an x squared, okay, if you had a y to the fifth, anything like that, if you have any exponents on the variable other than just a plain x or a plain y, that is not a linear equation. So you can't have any of these, okay? You can have an x, you can have a y, okay? The next attribute in an equation that would make it nonlinear would be any variables that are multiplied together. So if you're coming along here and you had, 3x plus 4x, y, something like that, equals, 7. This xy term, okay, can't have that. You can't have two variables multiplied together. That makes it nonlinear. The next attribute that would make something nonlinear would be any variables in the denominator of fractions. So if you're coming through and you've got an equation where you've got, say, 2x minus, 7 over y. Okay, that's a y there. Equals 13. Okay, you got a denominator that has a variable in it. That's going to mean that is not a linear equation. Okay, that's going to make an equation. It's going to make a line, but it's not going to be a straight line. Okay, that is a nonlinear equation. And the last attribute you want to keep your eye out for would be any variables as exponents. So let's say you had, 3 to the x plus 2y equals 7, something like that. This 3 to the x, okay, that means it's not going to be a linear equation. Okay, so those are four things you want to look at. Any exponents on the variable, any variables that are multiplied together, any variables in the denominators of fractions, and finally, any variables as exponents. Okay, so let's take a look at a few examples. Okay, for each equation, determine whether it is linear. So our first equation here is y equals 7x plus 1. Is the equation linear? Well, let's take a look. Do we have any exponents on the variables? No, no exponents on the variables. Do we have any variables in denominators? No, we do not. Do we have any variables multiplied together? Nope. Do we have any variables being used as exponents? No, we do not. So I'm going to come here and say yes, that is a linear equation. Coming down to this next one here, y equals negative 5x squared plus 3. Is the equation linear? Well, do you have any exponents on the variables? Well, yeah, we do right here. That little 2 there says that this is not a linear equation, okay? That's an exponent on the variable, can't have that. Moving along, next one here, y equals negative x. Do we have any exponents on the variables? We do not. Do we have any variables multiplied together? We have a y over here, we've got a negative x over here. We do not. Do we have any variables in the denominator of fractions? Again, we do not. And lastly, do we have any variables that are being used as exponents? And we do not. So that is going to be a linear equation. That's it. That is a linear equation. If I graph that, that's going to make a straight line. And last but not least here in our table, y equals 4. Well, let's go through our steps. Do we have any exponents on the variables? We do not. Do we have any variables that are being multiplied together? We do not. Do we have any variables in the denominator of fractions? We do not. Do we have any variables being used as exponents? And again, we do not. We simply have y equals 4. Now, there is no x here, and that's okay. This actually makes a straight line. We're going to talk about this a little bit later in this unit. Okay, if those are my axes, if I'm graphing the line y equals 4, that's actually a horizontal line that looks like that, going right through the point here, 0, 4. Okay, and that does make a straight line. Doesn't have any of the attributes that we talked about. So there's your first set of examples. Let's take a look at another set. Okay, in this set of examples, we're going to determine if the equation is linear. If it is, we're going to write it in standard form. Remember, we said that was a times x plus by equals c, okay? ax plus by equals c. Let's take a look at that now. Okay, is the equation linear? So we start off here. Do we have any exponents on our variables? Well, I got an x to the second power, x squared, so right there, that tells me this one is not linear, so I am done with that because we cannot write it in standard form. B, y equals x cubed. Again, I've got a power there, so that is going to be nonlinear. C, y equals negative 7x. Do we have any exponents on our variables? We do not. Do we have any variables being multiplied together? We do not. Do we have any variables in the denominator of fractions? We do not. Do we have any variables being used as exponents? And again, we do not. So right here, that's going to be yes. I'm going to bring that right up here. I'm going to work on getting that into this form. ax plus by equals c. So I have y equals negative 7x. Now, eventually, I want it to look something like this. I want my x term out in front plus my y term equals another constant. So right now, my x term is on the right side. I want it over on the left. To do that, I want to move this from this side to the other side. So I'm going to add 7x. If I add 7x here, I'm going to add 7x here. Now, be careful. Do not go ahead and add to this y, okay? This y is actually going to drop right down. Okay, it is a positive y based on what we started with, so that's going to be plus y. Okay, and I have nothing here to start with. I'm adding 7x to no x terms, so that's going to be a positive 7x. 7x plus y equals, well, 7x minus 7x is 0. Okay, when those cancel out, I'm left with 0. Now I'm in standard form. Okay, I've got my x term first, I've got my y term, and I've got a constant. So, yes, I am in standard form. I'm just going to erase part of that because I don't need that all the way down there. Okay, taking a look at our last problem here. dy equals negative x plus 3. Okay, do we have any exponents? We have no exponents on our variables. Do we have any variables multiplied together? We do not have any variables multiplied together. Do we have any variables in the denominator of fractions? We do not. And do we have any variables that are being used as exponents? Again, we do not. So that's going to be a linear equation. Now I'm going to bring this one right over here and try to put that one in standard form. So I have y equals negative x plus 3. And just like the last one, I want to get my x term from the right over here to the left. So I'm going to add 1x here. When I do that, I got to do that over here as well. Okay, those do cancel out to 0. Now I'm left here with x plus, because that's a positive y equals 3. Great. My a in this case would be 1. My b would be also 1, and my c is 3. Fantastic. I have a linear equation, and this would be that equation in standard form. Okay, coming down the home stretch here, let's take a look. Is the equation linear? X plus 7 over y equals 0. Do we have any exponents on our variables? We do not. Do we have any variables being multiplied together? We do not. Do we have any variables in the denominator of equations? We do, right here, okay? So I'm going to say that's nonlinear. Okay, take a look at this next one. 3x plus 6 plus 5y equals x minus 4. Okay, do we have any exponents on our variables? We do not. Do we have any variables that are multiplied together? We do not. Do we have any variables in the denominator of equations? Denominator of fractions, rather? We do not. And do we have any variables being used as exponents? Again, we do not. So that is linear. Bring that right up here. We're going to get that into standard form. Okay? So I have 3x plus 6 plus 5y equals x minus 4. Okay. Going through. I want to get all my x's over here out in front. So I got 3x here, I got 1x here. I'm going to subtract an x from each side. Okay. That's going to go away. I have 3x minus 1x gives me 2x. Everything else is going to come down. Okay. Now I've got my x over here, I've got my y over here, but I also have this 6 here, okay? I need to have all my constants over here. I only have an x term over here and a y term over here, so I'm going to get rid of that 6 by subtracting 6 from both sides. Okay, that's going to go away over here. That leaves me with 2x plus 5y equals negative 4 minus 6 is negative 10. Fantastic. So now I have my standard form of this linear equation here. Let's take a look at C. Do we have any exponents on our variables? Well, yes, we do, right here. Easy enough, that is not a linear equation. And lastly, for D, do I have any variables on my linear equation, on my variables rather? Any exponents on my variables? I do not. Do I have any variables multiplied together? I do right there. Okay, so I got x, y, that's going to say that's nonlinear, and we're done. That's it. So after these notes, you should be able to identify whether or not an equation is a linear equation, and then if it is a linear equation, go ahead and put it into standard form. If you have any questions, see me in class. Thank you.